If you go to unifi.ui.com, go to Ubiquiti's Site Manager, you can use the so-called Site Magic to connect your internal networks for different sites from different locations and combine them together just like a single site. So it's a very convenient way to enable the network communications among your multiple sites. And they will be connected through internet, the very affordable way. In fact, UniFi Site Magic is Ubiquiti's take on SD-WAN. SD-WAN stands for Software Defined WAN. It uses software-defined networking technology such as communicating over the internet using tunnels which are encrypted when destined for internal organization locations. And Ubiquiti's implementation of Site Magic included two major technologies. First, the VPN mesh, so that the multiple sites can be connected to each other. And the second thing is about routing. For the connections among sites, Ubiquiti uses WireGuard. And for the routing, Ubiquiti uses OSPF. In this video, let's look into the backend to see how Ubiquiti's Site Magic is implemented and how it works. In this video, I'm going to use 3 sites at different locations. As you can see from the lower part 3 windows, for each site, it has its own VLANs or subnets. And my goal in this video is, as shown in the diagram, I want to combine different VLANs from different sites together using Site Magic. Of course, to make the connection possible, the system needs to set up the site-to-site VPN, right? But the Site Magic makes the VPN setup part effortless. Let's see how it works. In the upper right of the screen, the Site Manager, I'm in the Site Magic tab. Click this link to get started. By default, all the 3 sites are included in your Site Magic group setup. But just to make it simple, for the first step, let me only include 2 sites. Okay? After you click Add, Ubiquiti really needs to add more details to the error messages, because many times the error is very confusing and misleading. Let me show you. Click the Add button. See, for site 1, it doesn't complain anything, but for site 2, see what's the warning? These site subnets are overlapping, but it doesn't tell you what is overlapping exactly. So in the lower part of the screen, if you compare the subnet situation for the 2 sites, someone may say, okay, is the error due to the fact that you have VLAN 10 in both sites and they have the same subnet setting? Is that the cause for the error? In fact, this error we are facing now, it has nothing to do with the overlapping between the 2 sites. It's only complaining just within site 2, I have some overlapping issue. But if you just check the subnet situation now, there's no overlapping at all, right? It turns out this error is due to a totally seemingly different thing. It's about routing, about OSPF. So in the site 2, I do have a OSPF setup. So this OSPF setup result in subnets overlapping, but you cannot directly tell from your network setting. That's why many times this type of warning is so confusing. Another possible reason for the error or warning is you may have some VPN setup and your VPN's subnet may conflict. Okay, so anyway, to make it work, I have to remove my OSPF setting for the second site. Let me do it. Okay, removed. Now let me go back to network. See, I have 0 change about my network here, right? But see, all of a sudden, the Site Magic automatically refreshed. Now there's no error or warning anymore. It showed all my subnets for site 1, all the subnets for site 2. some of them are grayed out, especially all of the internet network, because we are talking about site magic. Of course, it makes sense to disable the network for internet. For site 1, I want to use VLAN 12, site 2, VLAN 30. So let me select the subnets accordingly. In the right side, site magic, VLAN 12 for site 1, VLAN 30 for site 2. Connect. Okay, done. That's how easy it is to use site magic to connect your sites. Let's briefly validate it works. Then we go to the backend to see how it's implemented. On the screen, I show you two Linux virtual machines. The left one is for VLAN 12 within site 1, and the right one VLAN 30 for site 2. We can easily confirm their subnets. The left one 12 and the right one 30, right? Because they belong to different sites. Of course, without the site magic, they shouldn't be able to connect to each other, right? But now the site magic is done. Now let me ping the VLAN 30 machine from the VLAN 12. Okay, it's pingable. Then from right side, ping the left side. Okay, also pingable. You can see they are able to connect to each other, which means first, the site 1 and the site 2 are connected. Why? Because internally, VPN connections are established. Second thing is the routing works automatically. I haven't gone into the system to configure the static routing, and the system automatically route the packets between the two sites, between the two subnets. By the way, you need to make sure your existing firewall rules won't prevent this type of communications. For example, if for VLAN 12, initially you have a block inter-VLAN traffic, your initial purpose was to block the communications within the same site, right? But now you want to connect it to another site, and another site's local networks, they are also using the private network subnets. So you need to check your firewall rules if the communication is not successful, even after you establish the site magic connection. Okay, this is easy to validate the connection, but now let's try to understand how the magic works within the two routers. Let me SSH into the UDM Pro and the UX3 Pro for the two sites. Okay, I'm in. Then from the site 1 router, let me first show the current routing IP route. Okay, almost all the routing rules existed before the site magic configuration. The only new changes are the two highlighted lines. The second line is about how to route to site 2. It's routed through the device WGSTS1000, which is defined in the first line. This interface has a strange name, and just by checking the name, I guess it is using WireGuard VPN because it begins with WG. So to confirm that, let me see whether we have any WireGuard configurations are being used at this moment. Let me see whether under run folder we have any WireGuard configuration file. Yes, we do. Then let me display what's inside this configuration file. Okay, it defines the interface, then configure how the authentication works. It has this line to configure the allowed IP address. This is the WireGuard interface configured in site 1 as shown in the diagram as well. So we have a interface with this IP address. It is supposed to connect to the right side peer endpoint in site 2 as shown in the configuration file. The site 2 has this IP address and using this port number. And in the right side site 2, we should have similar configuration file. Let me show the WireGuard configuration file in the right side. Okay, yes, we have a corresponding one. It's very similar with the same interface name, different IP address, and for peer, it is for the site 1. So as shown in the diagram for site 2, we have this interface configured for WireGuard. It's supposed to connect to the left side peer endpoint. Okay, so the system automatically created 2 VPN connections to enable the communications. So this type of VPN configuration is called VPN mesh. So the reason I want to first show you only 2 sites is for this special situation, the VPN mesh is very simple. We only have 2 VPN connections, right? So later you can see for 3 sites, we will have much more. And with the increasing of site numbers, you will have much more complicated meshing for VPN connections. Okay, now we see how these 2 sites are even connected. The system automatically created VPN mesh, and more specifically is using WireGuard VPN. Now let's investigate how the routing works. When configuring routing between 2 routers, the first thing most people think about is static routing. So in UniFi Network Controller, if you go to routing, there's a tab for static routes. So you can manually configure the routes. It is not difficult at all if we are only talking about 2 routers. But this is not used in SiteMagic configuration. The reason is with the increasing of router numbers, to maintain and configure the static routes will become more and more tedious, error prone, and will be very difficult to manage. So instead, Ubiquiti chooses OSPF in the SiteMagic configuration for routing. So this is a Wikipedia article for OSPF, which stands for Open Shortest Path First. It uses link state routing algorithm operating within a single autonomous system. Let's go to the system to see how OSPF is configured. Of course, Ubiquiti won't start from scratch to implement OSPF. It must be using some matured free software package from the market, right? So let me do some investigation works in backend. So I know OSPF use port number 89 in the SSH session. Let me check what process is listening on port 89. I'm running netstat command. I only want to see 89, and only this row is for port 89. Here you can see the process name is called OSPFD. It already implies it may be using FRR. Later I will show you, but let me confirm it. So let me run OSPFD, just show the help. See, the URL is FR routing. You may hear of FRR in the past. It's a very popular package to support advanced routing. So this is FR routing project webpage. If you are interested, you can look into its documentation. But in this video, we will directly use its built-in tool to check the configuration. FRR comes with a virtual terminal shell. It's called VTYSH. It's an interactive environment to do the configurations. So let me go back to the SSH session. Let me run VTYSH. Okay, I'm in. Let me show the current existing configuration. So now it's clear, right? You can clearly see how the OSPF is configured. See this interface? We just saw it. It's configured using WireGuard. And then here comes the OSPF configuration, including how it's authenticated, what's the cost configuration. And here you can see several important parameters for OSPF just to help us understand the configuration. In the UniFi Network Controller webpage, let me go to Ubiquiti's OSPF configuration. You can see now it's disabled because we enabled SiteMagic. Even though all the settings are grayed out, you can still see what are the crucial parameters to configure OSPF. First, router ID. So the router ID looks like a IP address. as you can see here, but it's not really a IP address. It can be any number in this format as long as it's unique. The system will use it to identify your router. In the right side, let me run VTY SSH as well. Then show running configuration. Okay, here you can see in the right side for site 2, it has another router ID, right? So it's just a ID, not a IP address. Okay, and then you can see it has 2 network lines. So the first line is for how the traffic can be routed to another site. So this is the IP address for this WireGuard interface, and in the right side, this is the IP address for its WireGuard interface. Okay, so by using this line, the system will know how to route the traffic to the other site. And then the second line is for its own network, which will join the site magic configuration. Remember, for site 1, we chose to share VLAN 12, and for site 2, VLAN 30, right? That's why you see the second network line here. And then this area line is also important. It indicates the area ID. In the network controller, here I cannot show you, but you do see the areas here, right? If it's enabled, if you click the create new, you will be asked about AID. So the area ID is crucial. You can see these 2 sites in the left and the right, they have the exact same area ID. By the way, area ID also looks like a IP address, but it is not. It is just a unique ID in this format. Okay, and because these 2 sites, they share the same area ID, they will be neighbors. That's why later you will see they will exchange the network information automatically. Okay, we are not done with this line yet. See this part, authentication. Basically, for OSPF, you can say no authentication is needed, or you can configure it different ways. UniFi, configure it using message digest. This is how the OSPF is configured in the 2 routers. Now let's see it works in action by capturing the OSPF packets. Okay, this is the line of command I'm going to run. It's a little bit complex. Let me explain it. It has 3 parts connected using pipeline. So the first part, I want to run TCP dump to capture the packets using this WireGuard VPN interface. I want to write the data. And then the pipeline is I want to write the data to this file. The last part is at the same time, I want to display the captured packets on the screen. Okay, let me run it. Okay, it's running, and you can see the OSPF hello packets already, but let it run in the right side. Let me run the exact same command. Okay, run it. Yeah, it also captured hello packets. You can see from the left side and the right side, only hello packets are being captured. What is hello packet? A hello packet is a special data packet that sent out periodically from a router to establish and to confirm network adjacency relationships to other routers in OSPF. So now you see hello packets because the routers are confirming the network adjacencies, because we started capturing after the site magic was already done, right? So the network agency was already established. So that's why it's only doing the confirming work. So later we will see if we change the site magic, what new packets we will capture. But for now, let me stop capturing. Then in the left side Linux, let me run scp command to transfer the captured file from the UniFi router to the Linux local file system. Okay, done. The right side Linux, let me do similar thing, transfer the file. Okay, done. Then let me use Wireshark to open the file locally. Okay, now let's examine what's captured. As you can see, from this .0.0 IP address, it's sending the hello packet every 4 seconds. And then from the .0.1 IP address, it sends out hello packet also every 4 seconds. Then what's 00? See in the diagram, 0.0 is the IP address for the site 1's interface. .0.1 is for site 2. Basically, what we are seeing is site 1 send out the hello packet every 4 seconds. Site 2 is doing the same thing, right? Then let's examine what's in the hello packet. So in the lower part, let's expand the OSPF section. So let's check the header. See the version 2 OSPF router as indicated here. We just saw it in the OSPF configuration in backend, right? That's the router ID. And here it comes area ID, another important identifier. Only if the area ID is the same, they will be recognized as neighbors. Let's check the content of the hello packet. See, it says hello interval 4 seconds, just like what we observed. To decide whether the site is dead or not is another parameter, 10 seconds. Then here, see the site 1 announced, okay, I have a active neighbor, which is this one. What's this one? See the diagram? This is site 2. So basically site 1 is announcing I have a active neighbor, which is site 2. And then if you check in right side for the hello packet sent out by site 2's router, you will see similar thing. See the active neighbor .0.0, which is site 1, right? So the hello packet is very simple and it is used to establish and confirm network agency relationships to other routers. Now let me go back to SSH, try to modify the site magic configuration for the two routers. I am back to site manager. Let me reconfigure the site magic group. So see for site 2, we only have the VLAN 30 selected, right? So now let me select VLAN 40. And before clicking on the connect button for the two SSH sessions, let me run the same TCP dump command so that we can see what new OSPF packets will be sent out. Okay, run them. So you can see the same hello packets are being sent, right? Because we haven't changed the configuration yet. Now let me click on the connect button. You will see some new thing. See here, LS update, and in the right side, LS update as well. You can also observe TCP dump command was stopped automatically. Why is that? Think about it. The system needs to reconfigure the site magic so that the WireGuard interface will be regenerated. Because for TCP dump, we were using those WireGuard interfaces to do the packet capturing. So that's why the TCP dump was stopped. But it doesn't matter because before it's killed, we already captured the information we need, which is the LS update packet. Okay, let me transfer the file to local file system, then display it using Wireshark. In the left side, I opened the captured packets using Wireshark. In the right side, you will see similar thing. So just to save time, let's only check the left side file. So you can see except for the hello packets, we have new thing captured, which is LS update. If you still remember what's mentioned in the Wikipedia article, LS stands for link state. This is a link state update packet. So let's see what's inside. Click on it and expand the LS update section. See, there's only one update, expanded furtherly. The right side router, the site 2 router, was advertising. Okay, now I have a new subnet. Remember, we added VLAN 40 to site 2, right? So that's the change, that's the delta. That's what the router 2 was advertising. This packet was sent out exactly from the site 2's router. Okay, And see here, it has type section. PTP means point to point. Remember, we are using WireGuard, and the VPN connection is point to point. So that's why here the type is PTP, and the ID is this ID. Why? This is our area ID, right? And then basically here it's saying, okay, router 1, now you may want to update your database about routing. Then let's check another packet sent from the site 1's router, and the type is link state acknowledge. So let's see what it is acknowledging. It's simply telling the router 2, okay, I acknowledge, you send me a update. And then later see here, the router 1, the site 1's router, is sending a LS update as well. Remember the first LS update was sent out by router 2, right? Now router 1 is sending it out. Why? Because remember, it's a autonomous system. So every router will update everyone about the new changes. So here in this captured packets, we don't see the exact subnet information for VLAN 40. I believe the reason is the TCP dump was interrupted because the WireGuard interface was regenerated, right? I believe after this, there were other packets exchanges, but unfortunately we cannot capture them. Okay, so this ends the discussion about 2 router scenarios. Before ending this video, let's check what if we have 3 routers, how complicated the situation will become. Based on the existing site magic group, let me change it by adding a new router. Edit site selection, choose site 3, save. Okay, now we see site 3 and its corresponding VLANs, and we need to select at least one. Let me select 255 as shown in the diagram. Now we have 3 sites, 3 routers, and for site 3, I add VLAN 255. Click. Okay, done. So in the lower part of the screen, now I have 3 SSH sessions to the 3 different routers. Remember, for 2 routers, we have 2 VPN connections, right? So let's see now how many we have for each site. Let me see in the run folder how many WireGuard configuration files we have. Okay, 2. Then for site 2, 2 files. For site 3, 2 as well. Let's examine them. Let me take site 3 as an example. Let me show the 2 files. Show the first file. Okay, so this configuration file is shown in the diagram as this one. So this interface is connecting to the peer end for site 1. Then for the second file, it's illustrated in the diagram as this one. It's pointing to site 2. So for site 3, it has 2 VPN connections to site 1 and to site 2, right? So similarly, if you check the other site's configuration files, you can see similar thing. So that's why in the diagram, you can see there are totally 6 VPN connections. So this is the so-called VPN mesh. If you have 4, 5, even more routers, it will be a very complicated net. So there will be much more connections. Just want to show you when you have 3 sites, what will be the VPN situation. Okay, and when it comes to OSPF, it works the same way. Okay, this ends this video. Thanks for watching.